Hey, what's up, Algebra 2s? How's that? A little better greeting, Mike and Brandon? Okay, here we go. So, Unit 2, Day 2, radicals, conjugates, and cube roots continued. All right, we're going to be doing now some adding and subtracting. So, we're going to do the same thing we did before. We're going to simplify these, if I can get my pen writing. The perfect square in 50 is 25. It's 25 times 2, and 25 is 5. So that is equal to 5 rad 2 minus this. The perfect square is 9 times 2, so that is 3 rad 2. And then this is rad 4 for 8 and 2, the perfect square of 2 rad 2. So this is just like when you learned in algebra 5x minus 3x plus 2x, except they're just radicals, okay? So it's 5 rad 2 minus 3 rad 2 plus 2 rad 2. They're all like terms because they have the same radicand inside the radical, okay? So that gives us an answer of 4 rad 2. Okay, and you can check these on the calculator by going to your calculator page, type this exact thing in the calculator. You're going to get an ugly decimal, which tells you it is irrational. And then you type this in the calculator, and you should get the identical radical irrational number. Okay? All right, so that is simplest radical form by combining your like terms. So here's another one to try. Now we have cube root as well as variables, okay? So all of the first step is everything we did yesterday. So I'm going to take this and I'm going to do this as what perfect squares are in 6? None. So 6 stays in the cube. I'm sorry, not perfect squares, but perfect cubes. Okay, a to the 4th, if I take it down 1, that's a to the 3rd, and it leaves an a. And b squared can't go in, so b squared. So this is really a to the 3rd over 3. So remember, power divided by root is 1, so that cancels to a cube root of 6ab squared. It's asking for a sum, so I know I'm going to add that to this. So now we need to find the perfect cube that goes into this. Okay, so the perfect cube, remember I told you go off to the side, 1, 2, 3, 4, 5, 6, and so on. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. Okay, this is x cubed, and you can do that quick on the calculator, leave it to the side. So now I see 162. I know I would want to start dividing in. We know 125 can't go into it. You would then try 64 into it. It doesn't work, but 27 does. So the perfect cubes are going to go over here. The perfect non-cubes are going to go over here. This is another method I showed you in class earlier today during Unit 1, Day 2. Okay, so this is going to be 27 times 6 is 162. A to the 4th, I need it to be a to the 3rd, because that a to the 3rd over 3 comes out, leaves me an extra a, and the b squared is too small. It's not divisible by 3. A power of 2 is not divisible by 3. So this comes out as the cube root of 27 is 3, and a to the 3rd cube rooted is a. And then the cube root of 6ab squared that couldn't simplify. So what we really have is an apple plus 3 apples. Since all of this are alike, it's just an apple plus 3 apples is 4 apples. And then the cube root of 6ab to the 2nd. Okay? So now we're going to get into multiplying and combining like terms where we have something squared. Notice this is the same exact term, so this could be written once with a square, or these, which everyone should know, are called conjugates. Okay, whoops. Conjugates. Oh my goodness. Thinking ahead here. Conjugates. Okay? Conjugates we've discussed many times. And while we were doing that, we were noticing in conjugates outer and inner cancel as well. So this is important. When we talked yesterday in day 1 about rationalizing a denominator, that you could not have a radical in the denominator, well, we can't have binomial radicals in a denominator either. That's kind of where we're going with this, okay? So the first one, if you had rad 3 plus rad 2 times rad 3 plus rad 2, so basically times itself, rad 3 times rad 3 is rad 9. Rad 3 times rad 2 is rad 6. Rad 2 times rad 3 is another rad 6, and rad 2 times rad 2 is rad 4. Well, rad 4 is 2, and rad 9 is 3. So these two can be combined to be 5, plus I have 2 of these. I have a rad 6 plus a rad 6. That gives me 2 rad 6s. That's it. That's all we can do with that. But conjugates, rad 3 times rad 3, if I am multiplying conjugates together, which means I have the same exact numbers, but one is a sum, one is a difference. The rad 3 times rad 3 is rad 9, but outer is a negative rad 6, where inner is a positive rad 6. They cancel each other. Then I have a positive times a negative is a negative, and rad 2 times rad 2 is rad 4. This is 3, this is 2, so it's 3 minus 2. Notice these are all whole numbers. Remember what we said about denominators? You cannot have something irrational. So whenever we're doing this, do you notice the radicals disappeared? Now this can simplify to 1, but it doesn't always have to come to 1, but it does need to come to a whole number, okay? So it asked you to explain what you notice about this, and know that explain means you need to say in words on the regions, okay? So what we want to say with this is that conjugates, when multiplied, eliminate irrational numbers, while squares, because this was a square, right? We were doing this times this, which could also be written as rad 3 plus rad 2 squared. Okay, squares do not. Okay, this is still an irrational number. This is rational. That's going to come into play when we do number 3 in class. Okay, so I'm not going to do that one with you. We're going to do these again. Knowing that conjugates eliminate, this is just rad 5 times rad 5, which is rad 25. The outer and inner will cancel. Then we will have a minus rad 9. Well, notice these are perfect squares. 5 minus 3 is 2, rational number. Okay, now this only happens with conjugates, so you must make sure that you have a conjugate first. 7, 7, rad 2, a sum, a difference. Because these are conjugates, just multiply the first 2, 49. Positive times negative, multiply the last 2, rad 4 is 2. You get your perfect number, okay? A whole number. So all these ugly irrational numbers, if you type this into the calculator, you'll get the whole number 2. Okay, and the last one, we do see a radical times a radical, which is rad 25. I see a sum, a difference, so multiplying is negative, and 2 times 2 is 4. So this gives me 5 minus 4. Again, I get the rational number 1. Okay? So in class tomorrow, I'm going to show you why that's so important with this. We said we cannot have radicals in a denominator. So when we did day 1, we knew we had to multiply. If I only had 2 rad 3 in the denominator, on Monday we multiplied by rad 3 over rad 3 to get rid of that. We can't do that this time, okay? So in class today, or tomorrow rather, you will see that we're going to have to multiply by its conjugate. 5 plus 2 rad 3 over 5 plus 2 rad 3. And the reason for that is these are conjugates, which will then reduce to a whole number in the denominator, and that's what we need. Okay? Any integer can be in a denominator. Integer meaning a positive or negative whole number. Okay? And then we'll finish this up tomorrow. So again, have a great night. I know Brandon and Mike, you don't like when I keep saying the same thing at the end. I don't know. Have a great night anyways. Celebrate being in math and understanding and being able to ask questions. How about that? Ciao.